This is not a story about the dinosaurs roaming the earth millions of years ago. This is really a story about water. Now, it may come as a surprise to you, but the water you drank today and the water in the shower you took today is the same water that these animals drank and bathed in. You see, water is indestructible. Nothing is ever added, nothing is ever lost. It is simply recycled. I'm Frank Field. Now, the trouble with water is that when it is recycled, it comes back at the wrong time, or it comes back at the wrong place, or we do the wrong things with it. What do you know about H2O? We'll tell you things about water you never knew. And we'll tell you things about the water you use that are unbelievable. From where we sit up here in the Metropolitan Life blimp, about 2,000 feet in the air, you get an entirely different view of water. It's everywhere. It's plentiful and it's free. This is the Atlantic Ocean. Blue-green water stretching endlessly across the horizon. There are 317 million square miles of ocean water enveloping the Earth.
We see but a tiny fraction. Up in space, the astronauts in their shuttle see most of the 317 million square miles as they circle the Earth. There are waterfalls cascading down from enormous heights in an unending torrent. There are the vast lakes dotting the surface of the Earth. All of this adding to the belief that there's one thing we need never worry about, and that's the availability of water.
But that's not true. Just imagine if we took all of the water in the world, the ice caps, rivers, underground, and streams, and put it in this one glass. How much of this water do you think would be usable for you and me? Do you think it'd be 50%, 30%, 10%, or 1% or less? What do you think?
I'd say 10%. 10%.
There's so much pollution, I think the percentage would be low.
I would say about 30.
10.
The correct answer is that most of the world's water is not usable. The only amount of water that's usable is less than 1/2 of 1%, just a couple of drops. And yet, each hour in this country, we use up 16 billion gallons of water. Remember that blimp? Well, 16 billion gallons of water would fill up 3 million blimps, enough to circle the Earth at least 10 times.
The water is there, but it's always in motion as part of the cycle. Which leads us to our next question.
Here on this hot, steamy jungle river, you can begin to see the beneficial effects of water on trees and plants. Now, trees and plants are growing, living. That means they breathe. It's called transpiration. The trees give off water. Now, here's an interesting question for you. How much water do you think a full-grown tree will give off in 24 hours? Do you think it's 10 gallons of water? Do you think it's 40 gallons of water? Or do you think it's 70 gallons of water?
10 gallons.
40 gallons. Let's go for 40.
I would say 40 gallons.
10.
Well, the correct answer is 70 gallons of water. Imagine the millions and millions of trees and plants around the world that give off water into the atmosphere as vapor. Some of that water vapor is visible to us. We don't think of it as water, but these clouds are water. And from these clouds comes the rainfall we recognize as water. Often the rain comes in the wrong time in the wrong place, and that causes flooding. Now, most people don't know how much water there is in an inch of rain. Now, how much water do you think there is in 1 inch of rain when it falls on 1 acre of ground, such as you see there now? Is there 7,000 gallons of water, 17,000 gallons of water, or 27,000 gallons of water?
27,000.
7,000. 17,000.
The correct answer is, for each 1 inch of rain that falls on 1 acre of ground, there is 27,000 gallons of water, enough to keep a human alive for 30 years.
But when it rains, most folks think that means there's plenty of drinking water. What they don't realize is that 2/3 of this rain simply washes down to the sea or evaporates into the air. Only a small fraction gets into our lakes or reservoirs. This reservoir feeds billions and billions of gallons of water to a major city. It's typical of the way we store water. So here's our next question. Where is most of the Earth's fresh water found? Is it A, in reservoirs, B, lakes or rivers, or C, underground?
I should imagine underground.
Reservoirs.
Underground.
I think more in the undergrounds.
The correct answer is underground.
The water that is underground, even in such locations as this, is 30 times greater than all of the freshwater lakes and streams combined. That water has been under this ground since the time of the dinosaurs, and as it's used up, it will take thousands of years to replenish. 80% of the nation's municipalities use underground water for public supplies. Here in Arizona, in 1 year alone, the water table fell by as much as 20 feet.
88 billion gallons of water comes out of the ground each day. Sometimes too much is withdrawn. The result, a ground collapse or a sinkhole.
For most people, this is the water story. It's an unending fountain, always coming up out of pipes where we want it, when we want it, and how we want it. And of course, it's free, and maybe that's why we misuse it.
There's 500,000 gallons of water in this pool, and it wouldn't take much to ruin it. All it would take would be 2 glasses of highly contaminated water, which leads us to our next question. Both of these glasses of water look alike. One comes from a well, that's an underground source. The other one comes from a lake, that's an above-ground source. True or false? Underground water never gets as highly polluted or contaminated as above-ground water, which is found in a lake or river. True or false?
False.
True. False.
Now I'm going to ask you the same thing. What do you think?
True.
The answer is false. This glass of water taken from a well, the underground source, is more contaminated than this glass of water taken from a lake, the above-ground source. The reason for that is this. Toxic material, once it is underground, often fails to dilute and disperse. Therefore, that source of water may be contaminated for many, many years.
So with just a fraction of the world's water available to us at any given time, the pollution of such sources becomes an environmental problem that must be dealt with. Because water is no longer free to do with as we please. It's expensive to maintain old water sources and to find or develop new ones.
It's wintertime here at the South Pole. The days are getting darker and the ice is getting thicker. And it's difficult to believe that 75% of all of the world's freshwater supply is in the thick ice that covers the North and the South Poles. That if we could just melt one glacier, we'd have enough water to feed the United States for many years. And if we could melt the ice at the South Pole here, there'd be enough water to keep the Mississippi River running for over 50,000 years.
There are, however, major freshwater sources closer to home. Which of these do you think supplies us with the most drinking water? The Great Lakes, the Mississippi, or the Ohio River?
Mississippi River, in my opinion.
Okay.
I think I'll take the Great Lakes.
The Mississippi. Of course, I'm from St. Louis, so.
The correct answer is the Great Lakes, which provides water for nearly 15 million people, primarily in Michigan and Wisconsin, but also parts of Illinois and New York State. The Ohio serves about 11 million people, and the Mississippi supplies some 9 million people through the middle of the country.
There's enough water for all of us. The only problem is it's in the wrong place and it falls at the wrong time. This reservoir behind me feeds a major city 150 miles away. So the question is, which of these cities do you think has to travel the greatest distance to get water? Is it New York City, Los Angeles? Do you think it's Chicago? Or do you think it's Houston?
Chicago. Los Angeles.
Boy.
Houston.
New York.
Okay.
The correct answer is Los Angeles. 50% of California's population is in the south, but most of the water is in the north. So using a giant series of tunnels and aqueducts, the water is transported hundreds of miles south to Los Angeles and surrounding communities.
No matter where the water is, it must be moved from one point to another. This waterway will extend for over 300 miles, bringing fresh drinking water from the Colorado River to Tucson and Phoenix, but at the cost of over $2 billion.
So our next question is, who uses the most of our water? Is it farmers? Is it industry? Power plants? Or just you and me?
My kids. No. Probably you and I.
People.
I think people, too. I would think there's so many people. Yeah, I think people do.
Power plants.
The correct answer is farmers. Agriculture uses the most amounts of water. You know, it takes a lot of water to grow food. It takes about 15,000 gallons of water to produce 1 bushel of wheat, and it takes 6,000 gallons of water to produce a dozen eggs.
Here's the next question. Which state do you think uses the most water per person in the home? Do you think it's people who live in New York, California, Idaho, or Hawaii?
I think California. New York.
California.
California!
The surprising answer? It's a tie. It's Idaho and Hawaii. The per capita use in both is nearly 600 gallons a day, and the reason? Both states have relatively small populations that use lots of water outdoors, and it all adds up.
In the past, most of us have been concerned about the germs in our water supply. Today, we're concerned about the rain that falls and the acid that's in that rain. We're also becoming increasingly concerned about the toxic materials and the waste in the sewage. Now, here's an interesting question for you. How much of this sewage do you think is pure water? Do you think 30%, 60%, or 90% of this sewage is pure water?
60%. 60%.
30.
I'll say 30.
The correct answer is 90%. Actually, it could be as high as 99%. It only takes 1% of waste to turn pure water into sewage. So why not get rid of that 1%? Well, we can, but it does cost money. And here you have it. Usable water from sewage. This is Water Factory 21. It's located in Orange County, California. And yes, it is a water factory. It makes fresh drinking water. And there may be a Water Factory 21 in your future.
It arrives here literally as sewage, and then the miracle of the water factory. Through a series of physical and chemical changes, the factory begins the process of emulating nature itself and making water.
And finally, the water goes through a reverse osmosis. It's a technique in which the water passes through a series of membranes. That leaves the minerals and the salts behind, and the fresh drinking water comes through the other end. That water is then injected into the underground water system, finally coming out into homes and factories. Sooner or later, all this water must cost money, and we must all pay.
And so while we do the wrong things to water, there is hope. We can reclaim that water, reverse the cycle, so to speak, but that costs money. But while water comes at the wrong time and the wrong place, engineering skills can solve that problem by preventing flooding, storing water, and guiding it to those who need the precious drops. When it comes to conserving water and making sure we have it when we need it, it's up to us. We must learn the value of this substance that most of us take for granted.
When the rains fail to come and people waste water, this is usually the result. I'm walking along the floor of a reservoir. Normally, this reservoir would contain water, and I would be 60 feet below the surface of the water. The reservoir has nothing but a thin stream running through it, where normally there would be 94 billion gallons of water covering the land surface as far as the eye can see. But the reservoir is empty. There's no scientific way of predicting when the next drought might come, and the only answer to that is conservation. Well, maybe one reason we don't conserve and treat water with respect is that things may not always look the way they seem to be. Now, here, for example, is a typical meal we're about to enjoy. There's a chicken dish, there's a veal dish, here's melon, salad, butter, bread, and milk. Now, how much water do you think went into producing this meal? 1 gallon, 25 gallons, 50 gallons, 3,000 gallons? What do you think?
Oh, I'd say about 1 gallon.
Oh, I would say 25 gallons.
I would say probably 50 gallons.
I think it would probably take about 50 gallons.
It's hard to believe, but the answer is D. A typical dinner takes almost 3,000 gallons to produce. A veal steak is 2,600 gallons. Chicken takes 400 gallons. Salad, 6 gallons. Melon and milk more than 100 gallons. And margarine takes about 90 gallons of water to produce. But water used for us isn't limited to the table. The Sunday newspaper takes 150 gallons of water. A new car is 39,000 gallons. A barrel of beer is 1,500 gallons. And 4 new tires are 2,100 gallons of water.
Farmers need lots of water to grow food, but we need to develop more efficient ways of using water. Here at Epcot Center at Walt Disney World, scientists are using new technologies, agroponics, hydroponics, to grow squash and to grow peppers. And you and I can use more efficient ways of using water. We each use 150 to 200 gallons of water a day. Now, where does it all go?
This faucet left open is wasting 1,000 gallons an hour. And this hydrant running for 24 hours will waste a shocking 1 million gallons. But let's get closer to home. Let's test your water IQ. Question: how much pure drinking water do you think we flush down the average American toilet with each flush? Do you think it's 2 gallons, 5, 7, or 10 gallons?
7 gallons.
2 gallons.
10 gallons. 7.
The answer is 5 gallons. In one day, you can flush away 50 gallons of water. True or false? Dishwashers use twice as much water as doing the dishes by hand. What do you think?
No, that's false. You don't use as much water when you use a dishwasher as you do by hand.
She's always telling me, I used to say, don't use the dishwasher, wash them by hand. She said, it's more economical to use the machine, and plus it gets it cleaner.
I think that you use more water using a dishwasher than you do by hand.
Well, the answer to that is false. The average dishwasher uses 15 gallons per wash, and doing it by hand takes about 30 gallons of water, twice as much.
True or false? A 10-minute bath will use 40 gallons of water, but a 10-minute shower will save you water. Do you think that's true, or do you think that's false?
I'd say false. False.
I think it uses the same, probably.
I think a shower saves water.
The answer is false. Showers use 10 gallons a minute, so while a 10-minute bath will use 40 gallons of water, a 10-minute shower will use up to 100 gallons of water. A shave each morning is a must. Now, how much water do you think is used in an average shave? Do you think it's 5 gallons? Do you think it's 10 gallons? Do you think it's 15 gallons? Or maybe 20 gallons?
I'd say 5.
How much would you say?
I shave with an electric razor.
Well, less than 5, I think.
The answer is a morning shave with the water running will use up about 15 gallons of water.
The lawn sprinkler in the suburbs is also a must. In a summer of lawn watering and gardening, how much water could you use? Do you think 50,000 gallons, 100,000, 200,000, or do you think 400,000 gallons?
I'd say 50,000.
I'll say 100,000. 100,000.
The correct answer is actually double that, 200,000 gallons of water. Sprinklers use as much as 100 gallons an hour, and a garden hose, when left running, can easily use 500 gallons in just a few hours. It took almost 40,000 gallons of water to produce this car. But the use of water just doesn't stop there. How much water do you think it takes for a typical car to go through a car wash? 20 gallons, 40 gallons, 60 gallons, or 100 gallons? Well, the correct answer, most car washes use about 40 gallons of water per car. That means that each year in this country, 160 million gallons of water are used just to wash the family cars.
This is sun-baked Tucson, Arizona. It's shortly afternoon and the temperature's already up to 100 degrees. If you spend a little time in this state, you suddenly realize how precious every drop of water is. That's why every well is registered in the state of Arizona, and all the water you use is metered. And the more water you use, the more costly does each gallon become. And that's why the people who live out here are water-wise.
We just try to watch the water because of the water bills. They're pretty high.
I don't water my lawn except between a certain time, like between 4 and 5 in the evening. And then I just wash the dishes once a day.
When I'm in the shower, I turn the water off when I'm soaping up, and then I just turn it on when I rinse off.
We have a water-conserving shower head. I turn it off when I'm brushing my teeth and also when I'm shaving. If I could get this one to cut our shower down by 50%, we'd save a lot of water.
Here in Tucson, where there has been a 30% cut in water usage, we have a perfect example of what can be done. Now here are some hints on how you can conserve water in your community.
Aside from repairing leaks in your pipes and faucets, which, as you've seen, can amount to a lot of wasted water, when you wash the dishes, you'll usually be better off running a full dishwasher than doing them by hand. Try taking shorter showers, 4 or 5 minutes maximum, or turning the water off when you soap up. Also, get yourself a flow restrictor for the shower head. They work pretty well nowadays. And don't forget, when you're shaving or brushing your teeth, turn the water off. You'll save up to 15 gallons right off the bat. And outdoors, take it easy with the sprinklers and hoses. You can easily use thousands of gallons and never even realize it.
Water is no longer free. It falls at the wrong time. It falls in the wrong places.
And when we have enough of water, we do the wrong things to it. Well, here in Arizona, they're learning how to come to grips with the problem. And we can take a lesson from their examples. This is Frank Field.